So far, we have heard a lot about hybrid simulation in civil structure, in earthquake simulation. So I'd like to talk about how hybrid simulation are used in other industries, like automotive, like wind energy, aerospace. Yeah. So some background information, and we all know that back 40, 50 years ago, and people start to study hybrid simulation. Actually, Steve Mahan was the first person in the world started hybrid simulation in 1973. So that's a long time ago, and since then, many professors and developed all kinds of methods in civil structure and different integration methods, different software, and did amazing work developing all kinds of methods. And in civil structure, real time and process static and software real time, all those things. And but hybrid simulation technology can not only apply to earthquake simulation, but can also be applied to other industries. And so I'm going to focus other applications for hybrid simulation, so that maybe you can get an idea. So first, I'm going to talk about in-ground vehicle, how hybrid simulation is used. And in-ground vehicle, there are many applications for hybrid simulation. And for example, so this is a system MTS developed. So the physical substructures are these four dampers. And the rest of the model, proving ground and the vehicle and the body, all those is in a numerical subsystem. And besides, so a lot of control stuff. So this kind of dampers are active dampers. So they connect to the electric control unit in the computer. So based upon different road, different situation, so the valves inside the dampers will change automatically. So to test this kind of complicated active damper system with electron control, and so people start to use this hybrid simulation method. So first you need a vehicle model and the proving ground, and including all the substructures except the damper. And so this is an open seat for automotive. And then for the hardware, running this real-time model, and we have a display system, and so this is our XPC target, and together with open threshold here. Not open threshold, but connecting software. And then this is a test control software, and so same principle, and you have a physical substructure analysis model, and target PC, in this case is displays, and connecting software, control software, and this is a real-time hybrid simulation. So, and during the vehicle development process, some companies, they focus on the damper development. So then they can run this hybrid simulation to optimize their damper design. So they don't need a vehicle and to develop their damper. So so Nissan and other companies use this approach. So here's a video. You see, simulating the vehicle on proving ground and going sideways. So the developers, they tune their damper and then run hybrid simulation and then adjust the damper again. So without going to proving ground, without putting the damper into real car, so they can find out. The best damper design and the damper tuning parameters. So save them a lot of time. So this is an example of hybrid simulation. So another example is suspension optimization, and so you have a car. Suspension tuning is very important, and for this application, and this is a Hyundai Mobis. They have a air spring type of suspension with a lot of electronic control stuff, and again, so this is an air control system connected to the vehicle computer and the electric control unit, and this is an active suspension. So under that, so we use this quarter car system, and this is the physical substructure. Rest is in the numerical model, and same thing these ways, and vehicle model, and coupled together with the SquamNet, and running real-time hybrid simulation, and to optimize the suspension design. So this is another example. So, and interesting enough, and we have used OpenFresco a lot to do hybrid simulation. So we thought, why don't we try OpenFresco in ground vehicle? So Dr. Shawn and developed this user-defined element inside Adams. And then, so that OpenFresco can talk to Adams through this user-defined element. And then, so Adams can model the vehicle, then the commands can send to OpenFresco, then send to our test rig, and then, so using OpenFresco to do hybrid simulation in ground vehicle. So this is an example, and this is a vehicle, a car, and inside there's a spring, and the spring in here is a experiment element, and actually tested with our simple loading system, and so this is the animation in the lab. So that's Adams, and OpenFresco starts, and so you see the OpenFresco starts, and the simulation starts, and then the bottom is the vehicle running on the proving ground, and as the vehicle running, and then send the command to OpenFresco to the test rig, and so this is a specific proving ground. So this is an example. OpenFresco, what we learned in civil structure can be used in ground vehicle. So same thing, in ground vehicle we do a lot of testing with a sophisticated road simulator. This is one kind of a road simulator, spindle coupled, and vehicle model is on top, and with the suspension and the steering, all those, yeah. So the body is not showing there, and again, we can use OpenFresco to simulate this test, send the command to OpenFresco to the test. Yeah. So, and so there's another video. Let's see. So this is the starting OpenFresco and starting Adams, and the bottom is the Adams simulation. So the model sends the command through OpenFresco to the controller to move the activity. So that's a hybrid simulation in ground vehicle, and now we have a more hybrid simulation application in ground vehicle. For example, driver in the loop, and the driver is the physical substructure, and all the vehicle proving ground, that's all in the numerical substructure. So evaluating the design even without actual prototype. So next, I'm going to talk about hybrid simulation in wind energy. And so we are working closely with Denmark Technical University, developing a new method to test composite structure like a wind blade. And because composite structure and it's nonlinear, and during the lifetime, it degrades. So and also the specimens are kind of long, and sometimes you just don't have the facility to do the test on a full blade. So then they test only part of it and model rest of it, and they use different programs like ANSYS and other softwares. So we need to connect OpenFresco with ANSYS and deliver the method to do hybrid simulation. And like I mentioned, for the blade, and it's a composite material, and during the service life, there will be cracking, delamination, so the property will change. So if you measure the load at the beginning and does fatigue testing at the end, the load you measured is different because the specimen is properties changed. A crack and the delamination, making the blade softer, and then the load is changed. So we propose hybrid simulation coupled with fatigue testing. So at the very beginning, so we do one set of hybrid simulation and get a set of loading for the subsequent fatigue testing. So you do a part of fatigue testing, and then the blade will degrade, and then we do another set of hybrid simulation. And in this second hybrid simulation, we will do the model update and considering the property change. And then after that, we do another set of fatigue testing, and then another set of model updating, hybrid simulation, and then continue up. So in this way, the fatigue testing considers the specimen degradation. So it's a more accurate fatigue test. So for composite material, for specimen with rubber, stuff like that, so this kind of hybrid simulation coupled with the fatigue testing approach is more accurate. And in wind energy, other universities and companies have done excellent work. So this work was done by Trinity University in Dublin, and so they consider so numerical structure is this tower blades, and the physical substructure is a liquid filled damper. So the damper is inside here, and then they simulate this kind of hybrid system, and during different condition, loading condition, wind, stuff like that, so that they can design this damper properly. So another example of hybrid simulation example was done by Norwegian Marine Research Institute, and so what they did was to model the tower, so to test the tower and the model, the blade and everything above. And so the numerical substructure is the blade, tower, and loading. And the physical substructure is a submerged, partially submerged tower structure. And actuators are applied at here to apply the load calculated by this numerical substructure. Yeah. So this hybrid simulation was quite successful. Yeah. So next, I'm going to talk about hybrid simulation in aerospace. So aerospace traditionally is a very conservative industry because the test standard is all tailored to regulations. So the when you have to do this test has to be this waveform, has to be in this setup. So everything is set up for you, and you cannot change anything. So as a result, for many years, and the testing method has not been changed. But lately, we see the trend. People want to do hybrid simulation, wants to improve their testing method, and use hybrid simulation to test the substructure and the components. For example, damper. We see different work and use hybrid simulation to test dampers. And also, we see the trend to use analysis model to help the tests to be run more smoothly, more accurately. And also we saw a lot for virtual testing to help setting up the physical tests. So in aerospace, hybrid simulation, same thing. And for example, I want to test a damper, and but the rest of the structure, the plane, whatever, the tire, the ground is all in the analysis model. So then, definitely, the model can be connected with the Open Fresco and to the controller and to do a hybrid simulation. Same thing. Yeah. So the approach is the same, just a different application. So we are setting an example at MPS to simulate aerospace testing. So we saw some researchers have done hybrid simulation in aerospace. So this is a work done by Bristol University, and they want to test a lag damper in helicopter, and the damper is in the lab and tested by actuator, and this is a real-time hybrid simulation, and the rest of the structure is modeled in Simulink. So in aerospace, and a lot of times the model is very complicated, so you need to do reduced order model. Dr. Gao just explained, so I'm not going to repeat. And also, we saw the trend to use model to help the physical test. For example, in some applications, FEA people, they set up their complicated models and they solve it, and they find out, okay, the strings in different locations. And then they tell the lab people, okay, and this is the string field we calculate, and it has 50 locations. The strings we want you guys in the lab to reproduce in the lab using actuators, and then so in the lab, and you have to go through optimization process, and the targets targets are the string readings from IPA model, and then you put the string gauges in the lab on those locations, and then you use the actuators, controllers through optimization process and achieve the string readings, string field. So that's an example of a model-assisted testing. And another application of model-assisted testing is, aerospace testing, like wind testing, has many actuators, maybe 200, and a lot of cross-coupling, complicated, and sometimes because of that, the test cannot be run very fast. So very slow tests, and then as a result, take a very long time. And then, so people are thinking to use different methods, compensation method, to make the test done more accurately, more stable. In that case, you can run the test faster, save a lot of money, time. Yeah. So you need to create some compensation method, the time series method, the H infinity method, can all be tried here. And so that if the stability issue rose up, and the compensators can quiet them down, and then tests can be run faster. So, and also, we see the digital correlation is used in aerospace more and more. So you use digital correlation and get the displacement and the string field accurately, and compare that with the FEA result. So sometimes even you need to use the digital imaging correlation signal as a control signal, and achieve those signals, and to avoid putting string gauges and stuff like that. So that's all what I want to say about hybrid simulation in other industries.
Thank you.